Hey guys, welcome to day 95. Very quick unit here. Test tomorrow. It looks like, by the way, I'll send an email for confirmation, but it looks like both Tuesday and Wednesday I will be doing a review session from 9 to 11 here at school. So I'll send that out in a confirmation email soon once I get total confirmation from the school that it'll be open. Okay, so what I have here is 5 sample problems. I'm going to write the problem, and I want you to try and solve it on your own. Like, pause the video, try and solve it on your own, and then check back and see if we get the same answers. Okay? So here's problem 1. I'm going to go through them fast just so we can get all of them done. Problem number 1. Solve for y equals f. Solve for y equals f of x when dy dx equals cosine x, parenthesis 4 minus y, for the initial condition f of 0 equals 1. Okay, so go ahead and pause the video there. Remember your separate, integrate, plus c, solve for c, solve for y. Okay, go ahead and try this on your own, and pause it, and then I'll solve it here shortly. Okay, the first thing we want to do here is we want to separate our y's and x's. So to do that, I'm going to divide over the 4 minus y, and I'm going to multiply over the dx. So it's going to look like this. You have to separate the variables. You get 0 points if you don't do that. So make sure you do that. Okay, now we have to integrate. dy over 4 minus y is going to be a natural log integral, but what I want you to pay attention to there is because that variable y is negative, it's going to be negative natural log absolute value 4 minus y. It's not because there's a minus, it's because the variable is negative. If it was y minus 4, it would be positive natural log absolute value y minus 4. Okay. Antiderivative of cosine is sine plus c. Okay. So you're going to get a point for each of those antiderivatives done correctly. Now we have to plug in the point f of 0 equals 1. So everywhere I see an x, I'm plugging in a 0. Everywhere I see a y, I'm plugging in the number 1. So I have negative ln absolute value 4 minus 1 equals sine of 0 plus c. Okay? 4 minus 1 is 3. Now this point is very important. Because I got a positive number in there, I'm going to be able to drop my absolute value signs at the end with no changes. Okay? The absolute value of 3 is 3, so I get negative ln 3 equals sine of 0, right? This is 0, so 0 plus c is c, so c equals negative ln 3. Okay? Then I go back and I'm going to plug that in here. Negative ln absolute value 4 minus y equals sine of x minus ln thirds, or ln 3. Now I just have to do the process. You get another point for getting c correct, right? Considering c and getting a correct c value. The last point tends to be the hardest for people to earn. We need to solve for y. Now you might say, oh, there's a natural log, let's get rid of it with e. But just chill for a second. I want to get rid of that negative out in front of the natural log before I do anything else. Okay? So right away I'm going to multiply everything in the equation by negative 1, so I just have natural log. Doing that, it looks like this. Natural log 4 minus y, absolute value of 4 minus y, equals negative sine x plus ln 3. Okay. Now I can raise both of these as exponents of e, because e to the ln of 4 minus y, absolute value 4 minus y, is going to make absolute value 4 minus y. So I can just say 4 minus y in absolute values equals e to the negative sine x plus ln 3. Okay. Now make sure that it's very clear that that's an exponent of e. You can't write e and negative sine x and plus ln 3. You can't write them all on the same plane. It obviously has to be a superscript there. Okay? Here's the place where sometimes if it's a multiple choice, you can just leave it like this, right? But if it was a multiple choice, they might simplify e to the negative sine x plus ln 3. This might be, they might simplify this to 3e to the negative sine x. I don't want you to make that substitution on a free response test, but I want you to be aware of that substitution, or that simplification for multiple choice purposes. But I'm going to leave it as e to the negative sine x plus ln 3 for the rest of this problem. Okay? Next, because when I plugged in my y value, what was inside of the absolute values was a positive number. It was positive 3. I can just drop the absolute value signs, and I can write 4 minus y equals e to the negative sine x plus ln 3. Now I need to just solve for y, so I'm going to subtract 4 from both sides, realizing that this negative is staying with the y, right? So negative y equals e to the negative sine x plus ln 3 minus 4. Now I multiply everything by negative 1 to get negative e to the negative sine x plus ln 3 plus 4. Make sure this plus 4 and this minus 4, make sure they don't look like part of the exponent. It wasn't part of the exponent. It was just subtracted or added after. Okay? A quick check here shows me that if I plug in 0 for x, I'm supposed to get y to be 1, right? This, when I plug in 0 for x, becomes 0, so I get negative 0, which is 0, plus ln 3. This e to the ln 3, right? The e and the ln are inverses of each other, so it just comes out to be 3. So I get negative 3 plus 4 equals 1, which is what it's supposed to. Okay? You don't have to write out the check. In fact, when I took the test, I would do it in my head. Okay? And I only did it if I had time left over. Okay? But it's a good way to check to make sure all your signs are correct. If you have time on the test, I want you to do it. If you don't have time on the AP test, just trust that you did it right. Okay, next problem. So there was our final answer. Okay, next problem. I want you to solve for the particular solution, y equals f of x again, when dy dx equals x squared y minus 5 over 2. And my initial condition is f of 0 equals 4. Okay. Make sure it says solve for the particular solution. I saw some people doing the solving when the question was actually asking you for an equation of a tangent line. All right, so be aware. Don't be solving for something that you're not asked to solve for. Okay, so how am I going to separate these? Well, the way that I'm going to do it is I'm going to divide over that y minus 5. I'm going to divide over that y minus 5. The x squared and the divided by 2 are going to all stay put on the right side of the equation. Okay? So it looks like this. And I'm going to multiply that x over. Now this step isn't an overly difficult step, but it's one that we have to do correctly. Okay? The other thing that I might do here is, In terms of performing an antiderivative, I like it when it's an ax to the n form. So I'm going to rewrite that as half x squared. You don't have to do that move, but it helps me see the antiderivative better. Now I'm going to integrate both sides. Perform my indefinite integral. Now notice it's y minus 5 here. The y value is positive, right? Everything is to the first power down there. So I end up with the positive natural log of y minus 5 equals. Now I have to bump and divide. I bump up to 3, and I divide by 3. And again, 1/2 divided by 3 is the same as 1/2 times 1/3. This becomes 1/6. Okay, you got to get that coefficient correct. So we get 1/6 x cubed plus c. Okay. Next, my point was f of 0 equals 4, I believe. Yep. So I'm going to go ahead and plug in 0 for x and 4 for y. So I get natural log absolute value 4 minus 5. This should be sounding some alarm bells in your head. Okay? Equals 1/6 0 cubed plus c. Okay? 1/6 of 0 cubed is just 0. So I get c equals, notice when I subtract these, I get -1. Okay, that's going to tell us when we drop our absolute values, we have to make the other side negative. Okay, but in terms of solving this thing, the absolute value of -1 is 1, so this is ln1 equals c, and ln1 we know is the value 0. So our c here is 0. Okay, but again, this is very, very important. That tells us when we drop our absolute values, we have to make the opposite side negative. Okay? So here's what we have. ln y minus 5 equals, I'm plugging that c in right here with y's and x's. And I can write plus 0 if you want, or you can just write nothing, because plus 0 and writing nothing are the same thing. Okay? So next, we don't have to get rid of the negative like we did last time, so I can go straight to my e. I've got y minus 5 in absolute values equals e to the 1/6 x cubed. Now here's the point that's really important. When I drop my absolute values here, I have to make this negative e to the 1/6 x cubed. Okay? And you'll see why when we do the check. Now solving for y, I have one more step. I get y equals negative e to the 1/6 x cubed plus 5. When you do your test, you'll see why, right? Again, our point was f of 0 equals 4. When I plug in 0, I should get a y value of 4. Well, plugging in 0 for x makes this whole exponent 0. E to the 0 is 1. 1 plus 5 is 6. That's why I have to have this opposite here. So I have -1 plus 5 equals 4. So again, my final answer here is y equals negative e to the 1/6 x cubed plus 5. Okay. Number 3. Again, whenever I pose the problem, I want you guys to stop and try solving it on your own. Problem 3. dy dx equals x cubed over y. I want you to solve for the particular solution. Y equals f of x. at the point f of 2 equals negative 4. Okay? When I separate these variables, I'm going to multiply dx to the other side. I'm going to keep the x cubed in place, but I got to get rid of that divide by y. I get it to the other side by multiplying by y. I end up with y dy equals x cubed dx. Okay. Y dy equals x cubed dx. You got to do that step right. Now we integrate. Obviously not a natural log this time because we don't have a y in the bottom. The antiderivative of y, we bump and divide and we get 1/2 y squared equals 1/4 x to the 4th plus c. Okay. Now I have to plug in 2 for x and negative 4 for y. So I have half negative 4 squared equals 1/4 of 2 to the 4th. Okay. Negative 4 squared is 16. 16 divided by 2 is 8. 2 to the 4th is, I know 2 cubed is 8, so times another 2 is 16. So I have 1/4 of 16, which is 4. And so I have 8 equals 4 plus c. C then would equal positive 4. Okay. I'm going to go ahead and plug that in for c up here. And I'm going to get half y squared equals 1/4 x to the 4th plus 4. Now I need to go ahead and get y alone. So I'm going to multiply everything by 2. That gives me y squared equals 2 times 1/4 is a half. X to the 4th plus 8. And now we come to a very important piece. We know that we could either have the positive square root or the negative square root of 1/2 x to the 4th plus 8. Which one do we need, the plus square root or the minus square root? Well, it depends on our initial value of y. When we notice here, our initial value of y is negative. That tells me that I need the negative square root. So y must equal the negative square root of half x to the 4th plus 8. I'm not going to simplify that anymore. But again, you can do your test. When I plug in 2 for x, I should get negative 4 for y. 2 to the 4th, right? 2 to the 4th here is 16. 16 divided by 2 is 8. 8 plus 8 is 16. The square root of 16 is 4. But that minus out there in front of the square root makes my answer negative 4. So it has to be the minus square root. On the AP exam, if you just write the square root of half x to the 4th plus 8, you will not get that last point for solving for y equals. Okay? You'll probably get all the other points, but you won't get that final point. Okay? That needs to be a negative. If you write plus or minus square root, you won't get the final point either. Okay? It has to strictly be the negative square root of 1/2 x to the 4th plus 8. Problem 4. Let's see, I'm doing pretty well on time here, so I should be able to get all 5 of these problems in. Here's problem 4. dy dx equals 3x y plus 1 squared. And again, I want to solve for the particular solution. Y equals f of x. And my point is f of 1 equals 1. So again, I want to solve this thing, and I start by separating the variables. Okay, here's where we need to be very careful. I'm going to go ahead and multiply the dx to the other side. I'm going to leave the 3x alone, but I'm going to divide by y plus 1 squared. This is a big, important little number there. Okay, so doing that, I get dy over y plus 1 quantity squared equals 3x dx. Okay? The question I want you to ask yourself is this a natural log problem? The answer is no. It's not natural log because it's y plus 1 quantity squared. Okay? This is going to be a bump and divide. Very important to see that. Okay? So when I integrate this thing, okay, I'm going to go ahead and think of this as y plus 1 to the negative 2. Okay. Notice all I did was rewrite it. So I kept the big S. Once I actually perform the antiderivative, I drop the S and add the plus C. Okay, so because what's in there is y plus 1, a U substitution, you don't even have to do it here. We can just keep the inside the same the whole time because its derivative won't come out to be anything other than dy. So I'm going to bump the power up by 1 to negative 1 and divide by negative 1. That's my antiderivative on the left side. My antiderivative on the right side, I bump and divide, so I get 3 halves x squared plus c. Okay. Before I plug in, again, this standard is entirely no calculator. I'm going to rewrite this to be easier to plug in and solve. I'm going to call it negative 1 over y plus 1. Because I can take this negative exponent and throw it down in the denominator as a positive exponent, and which I don't even need to write when it's positive 1. Okay. Equals 3 halves x squared plus c. Please make this substitution. Okay? Do not plug into your calculator to figure these things out. Make that substitution so you can do it by hand, because you won't have a calculator anyways. Okay, what the heck was my point again? Oh yeah, it was 1, 1. And I can't extend the page any farther, so I'm going to do my best to keep this short and sweet. So we got negative 1 over 1 plus 1 equals 3 halves 1 squared plus c. All this becomes negative 1 over 2. So negative half equals 3 halves plus c. So I have to subtract 3 halves. So c is going to equal negative 1 half minus 3 halves. That's negative 4 halves, which is negative 2. So my c value is negative 2. So I'm going to plug that in right here. And let me just go to the next page here. Negative 1 over y plus 1 equals 3 halves x squared minus 2. Okay. Now I got to get y alone. The problem is y is in the denominator. So I'm going to multiply it over without distributing. So I'm going to have negative 1 equals 3 halves x squared minus 2 times y plus 1. I don't want to distribute because I'm just going to have to factor back out. Now I'm going to go ahead and divide by 3 halves x squared minus 2, and I'll get negative 1 over 3 halves x squared minus 2 equals y plus 1. And then I got to subtract 1. And I get y equals negative 1 over 3 halves x squared minus 2 minus 1. Again, when I plug in the point 1, I should get 1 as an answer. When I plug in 1 here, I have 3 halves minus 2. That's negative half. Negative 1 divided by negative half is positive 2. 2 minus 1 equals 1. Okay? So this would be an acceptable answer here. One thing that you might see in terms of multiple choice, if it's multiple choice, they usually don't leave fractions within a fraction. So what they would do is multiply the top and bottom here by 2. Again, you do not need to do this on the exam. I'm just showing you for multiple choice purposes. Doing that, this would look like this. Y equals -2 over 3x squared minus 4 minus 1. Okay? Those are saying the exact same thing. I don't want you to make that simplification on the test because best case scenario, it just wastes time. Okay? But on multiple choice, you might see it written like that. Okay? So again, my final answer would say y equals -1 over 3/2 x squared minus 2 minus 1. This would be my final answer, but this could be a final answer on multiple choice. Okay? The last problem, I wanted to do one with letters. So here's number 5. dg dt equals 1/3 of 50 minus g. Again, solve for the particular solution, g of t, y equals g of t. Okay? So we're going to solve for that with the initial condition, g of 0 equals, what did I say? Oh, g of 0 equals 40. Okay? So once again, we got to get g's with g's, t's with t's. The one thing you might notice here, you guys have been doing a good job of dealing with this when you see it, is there's no t on the right side of the equation. That's okay. Just keep the 1/3 over there for our integral, and we'll divide over the 50 minus g. So we end up with this, dg over 50 minus g equals 1/3 dt. Going ahead and integrating this thing, I get, now pay attention, our variable is negative, so we get negative ln 50 minus g equals 1/3 t. Remember, integral of a constant, you just tack on the variable, plus c. Okay. Again, my initial condition is g of 0 equals 40. 0 is going to go in for t, 40 is going to go in for g. So I get negative ln of absolute value 50 minus 40 equals 1/3 of 0 plus c. 1/3 of 0 is 0. So I get c equals, now again, look here, 50 minus 40, that's going to make positive 10. Because that's a positive number here, when I come to drop my absolute values, I can just drop them. I don't have to flip signs like I did in problem, what was that? Problem number 2, I think. Okay? So I get negative ln 10 equals c. I'm going to plug that into my equation right here, and I got negative ln 50 minus g equals 1/3 t minus ln 10. Again, I've gotten almost every single point. To get that very last point, I got to solve this equation for g. Step number 1, get rid of that negative in front of the natural log. You got to do that step first. Very important to make this just way easier on yourself. So by doing that, I just have to multiply everything by -1. Doing so causes the 1/3 t to become negative 1/3 t. And the negative ln 10 becomes plus ln 10. Now I got to get rid of my natural log. I'm going to do that with powers of e. So I get absolute value 50 minus g equals e to the negative 1/3 t plus ln 10. Again, the simplification here that you might see on multiple choice, they might write that as 10e to the negative 1/3 t. It's the same thing, okay? But we don't need to make that simplification because we don't have to simplify it. It's good as it is. Now, when I drop my absolute values here, am I going to turn that e to a negative e? The answer is no. I can just straight up drop them. When I do that, I get 50 minus g equals e to the negative 1/3 t plus ln 10. I'm going to subtract 50, and I'll get negative g equals e to the negative 1/3 t plus ln 10 minus 50. And now I just have to multiply by negative 1, and I get g equals negative e to the negative 1/3 t plus ln 10 plus 50. Okay. And again, plugging in 0 for t should give me 40 for g. Think about that. When I do, right, this is my final answer here. When I plug in 0 for t, I get ln 10 as the exponent. E to the ln 10 is 10, but this negative makes it negative 10. Negative 10 plus 50 most definitely is 40, so we know we're right. Okay. That is it for today. Hopefully looking at those 5 problems helps get your confidence up for the test tomorrow. The test tomorrow will be solving these like this. This will be the majority of the test. I'll also have you sketching your own slope fields, and I'll also have you sketching solution curves. The tangent line equations and those second derivative things that we've practiced, you don't have to worry about those for tomorrow's test. Just to make it a little bit shorter, I won't include those. You will need to worry about them for the AP exam. But again, you won't need to worry about them for tomorrow. That's it for today. I'll see you guys tomorrow. Make sure you come early. Might be some bad weather in the morning, so leave early. Make sure you get to the bus stop on time so you can get here on time. And I'll see you tomorrow. Talk to you guys later. 2 chains. Bye.